So the next topic we are going to see is binary trees and its applications. So normally when we take into the operations on binary trees, insertion, searching, deletion, these all will be a few operations in binary trees. So in insertion, you'll be adding a new node to the particular tree. And in searching, we will be searching whether the node already exists or not. And the time complexity depends based upon the worst case will be O of n. And if it is a balanced binary tree, then it will be O of log n. And these all details we'll be seeing it later. And deletion is you'll be removing a node from the particular tree. So the applications of will be binary search trees. So binary search tree will be, it's different from a normal binary tree. Binary search tree will have in a binary tree, you can have values, any values in the left tree and any values in the right tree. But in binary search tree, there is a condition where the left subtree will contain smaller values than the root and right subtree will contain larger values than the root. So 50 is the root node here and compared to 50, 30 will be. So lesser value will be in the left side. And in the left side, you can see 30. So compared to 30, 30 is a parent node and in the left child we'll have 20, which is lesser than 30. And 40, which is greater than 30, will be as a right child. And coming to the 50, root node 50 is right node. You can see 70, which is greater than 50. Similarly, when you take 70, left node will be lesser, that is 60, and right node will be 80. And the applications are the dictionary. We can tell a few applications like dictionary, phone directories, student record management, and database indexing. So this we'll be seeing it one by one. And the advantages of all this binary search tree will be fast searching, and it will be since it is in an ordered way. There will be a fast searching here, and traversal, that is visiting a node, that is also very easier. And whenever if you want to update, since it is already in an arranged, in an ordered way, you can just update it efficiently also. And coming to the applications now, when we take dictionary applications, you know that in a dictionary, all the words will be in the alphabetical order. So when it is in alphabetical order, from A to Z, it will be in the ordered way. So when we want to take and search a word in the dictionary, you normally know like from where it starts. That is from if it is C, D, or E, then you know that the order E comes after D. So you will be going and searching after D. Okay. So this is how we keep on going and searching in the ordered way. That is since it is in the alphabetical order and it gives a fast word searching. And even if you want to insert any words, easy insertion will be there. And since it is maintains an alphabetical order. When you go to the phone directories will be storing the names either in the name or in the or phone numbers, but everything will be in a sorted way. So if you take a phone directory, normally they also prefer storing it in alphabetical, so it is easier to search the word name, or else if it is number wise, then that also will be easier. And student management record also binary search tree is only applied, where the student records will be arranged either based on the ID number or the roll number. It will be in order or in the alphabet also. You can take the, so the benefit will be you can have an efficient record retrieval. And database indexing, database use binary search trees, and mainly B trees and B plus trees are used here, which they will maintain and organize the index data for faster access. Okay, so these all, and since it has some indexes, you can in a company or in an organization, they'll have each employee will be having an ID, employee ID. So based on the ID, they can search it, retrieve the particular employee easily. So there will be a faster searching. And here also efficient insertion, deletion will be there and improved data performance. That is what is shown here. And next is the expression, next applications of binary tree is expression tree. So expression tree will be always having some leaf nodes will represent the operands and internal nodes will be operators. So as you see here, you can see here star plus. These all are internal nodes which has the which are operators. C, A, B or operands. Okay, so expression tree also has some kind of applications like compiler design and scientific calculators. It is used in mathematical software and in expression evaluation. So mainly used to evaluate the mathematical expressions. So we'll see it one by one. So first, when you take the compiler design normally compiler will convert a high level programming language into a machine code. So what it happens, it will first convert the arithmetic expressions into the expression tree. So first the arithmetic expression is converted into expression tree, and then the compiler will check for the operator precedence, and then it will optimize the expression. So in this all tree is used here. Okay, so what happens, what will be the benefit is, so first the program expression is converted into, before generating the machine code, it is converted into tree. So the benefit will be there will be correct operator precedence, there will be a faster code generation will be there, and code optimization is also there. Then comes the scientific calculators. Scientific calculators is it will evaluate the arithmetic and scientific expressions. Okay, the complex mathematical expressions will be first converted into normally an expression tree only, complex calculations. Okay, so first it is the expressions are converted into expression tree so that it automatically calculates the based upon the precedence. So it will handle the bracket correctly and it will maintain the operator precedence also. So finally the result will have the accurate calculations. Then comes the mathematical software. So you can have here a MATLAB, Mathematica, Maple. So how the expression trees are converted is the mathematical software will store these equations as the expression trees to manipulate and simplify them. So mainly it will store and manipulate the algebraic expression, you can tell. So the software will create the expression trees, it will expand the expression, it will simplify the equations, and also it will use the differentiate and integrate. And the benefit will be simplification, differentiation, integration, factorization. And mainly it will allow the mathematical mathematics instead of only numerical calculations, it will allow symbolic mathematics representations also. Finally is the expression evaluation, which will evaluate the arithmetic expressions in the correct order. Okay, all arithmetic expressions will be used, will be converted into the expressions in the correct order. And mainly this evaluation is usually done using post order traversal only, that is left, right, and root. Okay, and the benefit will be it will ensure the correct order of operations and also it simplifies the expression evaluation. Next comes the decision tree. So decision tree is a supervised machine learning algorithm which will make the decisions itself by asking some yes or no questions. That is, it will make the decisions by asking a series of yes or no questions from the, and also it starts from the root node and ends at the leaf node. So finally, leaf node will give us the prediction or decision. So here, just a simple example, rain. If it is yes, if it's raining, carry the umbrella, otherwise don't carry. And the applications include medical diagnosis, fraud detection, loan approval, customer segmentation, and disease prediction. So this, we will see these applications one by one. And the advantages mainly will be it is easy to interpret and also it requires only little data pre-processing, mainly used for classification and regression. Then coming to the explanation of the applications. Medical diagnosis, normally when you want to diagnose, a decision tree will be asking questions based on the patient's symptoms and the test results. So at each step it will narrow down the possible disease. Normally if you go, your doctors will be asking a series of questions, right? So medical diagnosis, so first it will ask like, if the patient is having a fever, yes. If there is a cough, yes. If there is a chest x-ray taken and it is abnormal, yes. If these all symptoms present, then we tell that it is pneumonia. Prediction can be pneumonia. And so it will benefit will be to help the doctors to make a quick and consistent diagnostic decisions. And then the fraud detection. Fraud detection is like detecting the fraud. Maybe it happens with checks with the unusual transaction patterns. For example, if the transaction amount it is usually higher than the normal what it does, yes. So then the location, normally we are taking from one place and now we are moving into a different customers usual location, then there is a different in the transaction. Then the card used within a that is between cities, the card is used between a short period of time. So it can't be right, because a person from when he moves to a city to city, it needs some more time, but there is a shorter transaction. So that is also an unusual transaction. So when these all happens, it is called as we can predict as fraudulent, that is fraud or genuine transactions, and detects the suspicious activities. Then the loan approval. So this here also decision tree is used based on the credit score, income, and the employment. If the credit score is above 700, then it is yes. Then is the monthly income above 50,000? Yeah, that is also right. Then is the applicant is having a permanent job? Yes. So if these all things are done, then the loan, the decision will be they will approve the loan. And if here, if any one of thing is not right, then the loan will be rejected. Then customer segmentation. So customer segmentation means a decision tree will group the customers based on the characteristics and the purchasing behavior. If the age is less than 30 and frequently the person is buying electronics, then you can tell that he is an energetic, technology enthusiastic, like a young a girl or a boy, whatever it is. And maybe in another category, like he buys only healthcare products and his age is above 50, then we can segment that particular customer as some senior health conscious customers. Like this, there are so many things where we can categorize the customer based on their behavior. Then disease prediction. Disease prediction is like based on some health indicators. The sugar level is high and BMI is high. Family history is also having diabetes. Then we can tell that he has a high risk of diabetes. So this is disease. This is all in this application. Decision trees are used. Then Huffman coding. Huffman coding is normally is a lossless data compression, which is used for assigning shorter codes. Shorter codes are being assigned for frequently occurring characters. Okay, so the applications will be, and normally we use for shorter binary codes for frequently occurring characters, for longer binary codes for less frequent characters. And here the applications are SIP compression, image, audio, video compression, and data transmission. And mainly the advantage will be lossless compression. Many information will not be lost. And storage, since we have compressed it, storage will be less. And if you want to transmit it to any other, like through mail or through any other thing, then transmission also, it improves the transmission. Next, we'll see it one by one. SIP compression. Normally, it compresses the repeated characters using short binary codes. Um, so the text and the other files, it will replace frequently occurring code characters with the short binary codes. Okay. And then, so mainly what will be the benefit can be, It has smaller zip files, faster storage, and quicker file sharing. Then image compression. So image will be containing some repeated pixel values. Huffman coding will compress these repeated values efficiently. So white pixels occur very frequently, so shorter codes. For example, if it is a black and white image, and black pixels occur less frequently, so it will be assigned with the longer codes. And the benefit of this will be it will reduce the image file size, and so that there will be faster transmission and it will save the storage space also. Similarly, audio compression also. It will repeated sound patterns. If it is there, it will compress by assigning shorter codes. And the same faster downloading and streaming. It has smaller audio files and etc. And video compression is also the same. Thousands of image frames with repeated patterns will be there. So these repeated values after motion estimation, compression will be processed and mainly used in MPEG and H.264. And these also, when it compresses, it will have a reduced video size and the bandwidth also will be very small. And next is the data transmission. Data transmission means it will compress the data before transmitting. So faster transmission, reduced network bandwidth, lower transmission cost will be there. Instead of, for example, I can tell you, instead of sending a 10 MB file, Huffman coding may reduce it to a smaller size based upon the data so that it is easier to transmit. Next is binary heap. Binary heap is a complete binary tree that that satisfies the heap property. Okay, and here there are two types, max heap and min heap is there. Max heap, the parent node is greater than or equal to its children. You can see here, 90 greater parent than all other children. And 70, this is greater. And 60, this will be greater than its child. Min heap will have parent node is smaller than or equal to its children. And this also mainly used in priority queues, operating system scheduling, digit class algorithm, and heap sort. Now coming to the explanation of the applications. So in priority heap, so priority I can tell you like starts with it stores the elements along with the priorities. So for example, in a hospital emergency room, critical patient will be given the highest priority. Serious patients will be given a medium priority. And minor injury, like lowest priority. Okay, and benefit will be so that the diagnosis or the patients can be treated effectively. Then comes the operating system scheduling. Here, there are so many processes which will be in the queue. In that, if you're assigning a priority, for example, process A has highest priority and process B has medium priority. So, A will be processed first as since it has the highest priority. Okay, and so the benefit will be fast, efficient CPU scheduling and utilization. So, reduced waiting time, these all will be there. And DigitCrus algorithm, it is finds the shortest path from the source. So what happens is if there are vertices like A, B, C, D, and D is having the smallest distance from the source, then D will be processed first. Then B is having the smallest distance. Now B will be processed next. So what happens is quickly it will select the next closest vertex and it improves the efficiency of the algorithm. So binary heap is involved here. Next is heap sort. Heap sort will build the maximum heap, okay, to repeatedly extract the largest element. And what it will do is it will place it at the end of the array so that it restores the heap property. So if, for example, if the array is 20, 10, 30, and 5, after the heap sort, it will arrange it in the ascending order, 5, 10, 20, 30. So there will be efficient sorting with O of n log n. Okay, and time complexity is efficient and does not require extra memory memory for another array. Next is syntax trees. Next application is syntax tree. So syntax tree will be representing the grammatical structure of a computer program after parsing. So how this is normally used is The compiler will construct an abstract syntax tree before optimization and the code generation. So the applications here is compiler design, code optimization, and program analysis. So in compiler design, I have already told you it will convert the source code into the machine code, and so that it builds up the syntax tree, and based upon that the compiler will check the program structure, verify the operator precedence, and generate the machine code. So this happens. So a benefit will be it will make the code generation very easier and also correctly represents the program structure. Next comes the code optimization. How the syntax trees are used here is the compiler analyzes the syntax tree to improve the program. Okay, without changing the output. Output will not be changed. So it will analyze the compiler will analyze the syntax tree. So benefit mainly, so it will simplify the expressions and removes the unnecessary operations. So when necessary operations are removed, normally you have a faster program execution and the reduced memory storage. And program analysis, it will detect the error and analyze the program structure properly. So mainly the benefit will be, since it is detecting the error and it is analyzing, what happens is it improves the code correctness and the quality. Okay. So here the compiler analysis tool will help to detect syntax and semantic errors. It will find the unused variables. It will analyze the function calls and etc. Okay. So next is the file and directory organization. Normally, binary trees are commonly used internally for efficient indexing and searching. So operating under root documents, pictures, under documents few files, pictures few files, etc. will be stored. Now applications will be operating system, file indexing, file search, operations. So operating systems, when it comes, you can tell that it will organize to files and folders as a directory using the tree structure called the directory tree. So easy navigation and files. When it is arranged as a files and folders, there will be easy navigation and management. And efficient storage also, and also the it will locate the files. This, when you arrange it in a tree, it will locate the files quickly and manage the directories efficiently. Then in file indexing, how trees are used is large database and file system will be using B trees or B plus trees. Okay. So here mainly it is used for fast indexing and retrieval. Then the file search operation. So normally when everything is arranged properly, it is easier for us to search the particular file because it is arranged in the order wise, in a directory wise. Okay. So there will be some kind of index where you can also search the file and reduce the time. Next, database indexing. Data tree-based structures allow databases to locate the records quickly without scanning every entry. Okay, it will not scan every entry, it will locate the records quickly. Okay, so the applications will be banking, e-commerce, and hospital databases, and few more are there. Banking systems, normally it will, all the customer records and transaction records are stored using mainly B trees, and B tree and B plus trees are used based upon the account number and transaction record, so that you can have a fast account lookup and transaction processing. So mainly the applications, we can tell it as customer account management, ATM databases, loan records, everything will be stored correctly. And e-commerce websites, how trees are used are online shopping websites store products in a tree-based index only. So that when you search for a laptop, normally it comes under electronics. You have laptops, mobiles, cameras. So it comes under electronics. So faster search and order retrieval. So if you want to search some fashion items, then fashion, want to search some clothing under fashion, you have men and women. Then if you are a woman, and then you have to search it accordingly. Applications will be, databases will be in order, customer information will be there, category organization will be there, and product search will be there. And hospital databases will maintain a large, it will store and index patient records based upon their IDs, and it will organize, they'll have a patient ID, and tree will help to locate the patient's ID, patient's records easily. There are laboratory reports, patient records, medical history, appointment scheduling, everything comes here. So that they'll have a quick access to the patient information and efficient record management. Next comes the game trees. Game trees represent all possible moves in the strategic games. Okay, so there are so many games here which uses min max and alpha beta pruning. So these all comes in AI. So but that in AI artificial intelligence also this trees concept is used. So a chess engine will use a build a game tree by considering all the possible moves for both players. Okay, so there will be opponent responses. So which will help to, so either you have to move backward or move F3 or bishop to move C4. So these are so many moves which which is used in the chess. Okay. And this will help to choose the best move and improves the chance of winning. Then tic-tac-toe, everyone knows the game X and O. So once X and O, that based upon the condition. So these also follows a tree technique only, and it guarantees the best possible outcome. Similarly, checkers. Checkers also makes the all possible moves and predicts the future moves using a game tree only. So this will capture the opponent place and it will move to a safer position. And benefit will be selects the most strategic move. Similarly, Go and other artificial intelligence also, robotics planning, game playing programs, then strategy simulation, automatic decision systems, everything use the AI concept in which trees are involved in, which will help to make right decisions. And next is the AI. Binary trees are widely used. This all we have already seen it. That is in decision tree, game tree, that's before the previous slides which we have seen, and rule-based systems and knowledge representations. Rule-based systems will be used to represent, other two we have already seen, represent the rules in the form of if-then decisions. Okay, if-then decisions. Patient has fever, yes, na, then cough, then no means healthy, again cough, yes or no. So like this if then will be there, keeps on going, mainly used in medical diagnosis, customer support and everything. And benefit will be faster decision making. Knowledge representation means it will be a trees organized knowledge in a hierarchical structure. Okay, for example, animal, under that mammal. So under mammal, what all comes? Dog, cat. Similarly, animal, under animal, you are categorizing mammal and bird. So then bird comes, bird, under bird, eagle and sparrow. Like that, so many things are there. So it organizes information clearly and enables efficient searching. Okay, applications will be in rule knowledge representation is used in intelligence search systems, semantic networks, etc. Okay, and applications of binary trees is network routing and image processing. So network routing is routers also use tree-like structures to determine the best path to forward the data packets from the source to the destination. Okay. So if the packet, for example, there are so many routers like router A, B, C, D, E, and if the packet needs to reach router E, the routing tree will help. From router A to router C, you have to move, then you have to move to router E. So then it selects the path accordingly and decides you to take the best route. So this main applications in network routing will be internet routing, computer networks, wireless communication. And the benefit will be it will find the shortest path, it will reduce the network congestion, and it will prevent the routing loops, and it will speed up the data transmission also. And then comes the image processing. Tree structures can represent image regions as a quad tree. So it will use as a quad tree, which is a special type of tree to represent the images. Now, quadtree, what it will do is it will divide the image into four smaller regions repeatedly until each region is uniform or simple enough. So, an image you are dividing into Q1, Q2, Q3, Q4. If one region still contains so many details, then once again you can divide it into few more parts. Mainly used for image compression. Applications will be image compression, then satellite imaging, processing, computer graphics. Benefit will be you will get a smaller image size, faster processing, saves the storage space, and enables faster searching. Now, advantages of trees will be it has efficient, you can represent the efficient representation of hierarchical data, fastest searching and sorting, and recursive operational is also very simple. And if the tree is balanced, like you can apply in binary search tree, AVL trees, red black trees, and heaps. And it is widely used in databases, operating systems, compiler design, and in artificial intelligence trees. Disadvantage will be performance will regrade if the tree becomes skewed or unbalanced. If it is a left or right skewed, or if it is not balanced, what happens is it will be tree will be performance will degrade. Dynamic memory allocation will increase if because why? Because there will be memory overhead and dynamic memory allocation increases and more complex to implement normally than the linear structure. And traversals also sometimes may consume additional stacked memory for if it is the tree is very deep. Hope you have all understood. Thank you.